Have you ever stopped to wonder how scientists actually keep track of the millions upon millions of molecules that make up our world? Well, today we're going to tackle one of the biggest information challenges in all of science. How do you map the entire universe of chemistry? We're using the Organic Chemist's desk reference as our guide, and we're about to see how a century of sheer human ingenuity managed to bring order to what was, basically, chemical chaos.
Okay, so put yourself in a scientist's shoes for a second. You've just had this amazing breakthrough idea for, say, a new medicine. But first, you have to know if the molecule you're dreaming up already exists. I mean, where would you even begin to look? You see, this isn't just a chemistry problem. It's a massive, colossal information management problem.
And the scale here, it's just mind-boggling. By April 2010, the Chemical Abstract Service, or CAS, had already cataloged over 53 million unique substances. That's 53 million individual dots on a map that's just getting bigger every single day. So how on earth did we even start to navigate this chemical jungle?
Well, for nearly a century, the answer was paper. An unbelievable, meticulously organized, and absolutely gigantic amount of it. Let's take a look at the first great tool that tried to bring some order to all this molecular chaos.
This timeline really tells the story of chemical abstracts, the original paper map for every chemist out there. For a full 100 years, starting way back in 1907, it was the definitive guide. But check out that key year, 1967. That's when computers first started to enter the picture, introducing unique abstract numbers and giving us the first hint of the digital revolution that was coming. And then by 2010, the print era was officially over, an incredible end of an era in science history.
So what exactly was chemical abstracts? Well, it was what's called an abstracting service, but everyone just called it the key to the world's chemical literature. The idea is actually pretty simple, but it's incredibly powerful. Every time a new discovery got published, chemical abstracts would write up a short, concise summary, an abstract, and then index it like crazy, making it findable for any researcher in the future. And this system was way more sophisticated than just one giant book. No, it was this whole network of interconnected indexes. You could search for a molecule by its official name in the chemical substance index, or you could look up its formula, like C6H6 for benzene, in the formula index. You could even track down research by a specific scientist in the author index. It was, for all intents and purposes, a powerful, if very slow, manual search engine built completely out of paper. But there was a huge problem. A single chemical can have dozens of different names. You've got common names, trade names, super long systematic names. To create a map that worked for everyone, everywhere, chemists needed a single, unique code for every single molecule ever discovered. And the solution was so elegant and simple: the CAS registry number. It came out in 1965, and it's basically a unique ID number. The brilliant part is that the number itself means nothing chemically. It's just a tag, like a social security number for a molecule. This makes sure that whether you call it acetaminophen or Tylenol, the system knows you're talking about the exact same thing. Problem solved. And the process for getting one of these numbers is actually really straightforward. When a scientist publishes research on a new molecule, a human analyst, a real person, at CAS reviews it. They verify the new substance, add it to the registry, and boom, it gets a unique number that will identify it for the rest of time. It's like an official birth certificate for a molecule. So this whole system of abstracts and registry numbers built an incredible foundation. But the next leap forward would totally revolutionize how scientists explored this chemical library, taking them from the slow world of print to the lightning-fast world of pixels. And the difference is just night and day. In the old days, a serious search meant a trip to the library to haul these massive, multi-volume decennial indexes off the shelves. These were huge books that collected a whole decade of research, and you could spend weeks, maybe even months, just cross-referencing everything. The system was amazing, but it was collapsing under its own weight. And today, you can log into a database like SciFinder, ask it to find every known molecule with a specific atomic structure, and get a direct link to the original papers in seconds. It's just incredible. And today's tools go way beyond just finding one molecule. The modern chemist has this whole digital toolkit for whatever they need. Trying to figure out how to make something, CAS React has over 17 million reactions cataloged. Need to buy a chemical to start an experiment? ChemCats has you covered with 34 million commercial options.
Worried about safety regulations? ChemList is the go-to directory. And the portal that brings it all together is SciFinder. It's the difference between having a single paper map and a whole suite of specialized, real-time GPS navigation systems in your pocket.
So we have this incredible system, built over a century, but why does it all matter? Why go through all this trouble? Well, the answer is all about what this amazing library of knowledge lets us discover.
I love this quote from the preface of our source text because it gets right to the heart of it. Chemistry is massive, and it can be really intimidating. This whole system, from the very first paper indexes to today's digital databases, it was built by scientists for scientists to make sense of that overwhelming complexity. It's a very human solution to a massive intellectual puzzle. And the payoff for all that work is just enormous. This organized library makes developing new medicines faster. It fuels innovation in wild fields like materials science and nanochemistry. It even helps create more sustainable green chemistry by letting researchers find better, less wasteful ways to do things. But at the end of the day, it lets each new generation of scientists build on a century of organized knowledge to truly stand on the shoulders of giants without getting completely lost in the library.
So, this whole incredible story leaves us with one last big thought. We've seen how an entire community can build a system to map its universe of knowledge. If we can do this for chemistry, what other complex, sprawling field of human endeavor do you think is desperately crying out for its very own desk reference? Something to think about. Thanks for joining me on this one.